Hello viewers, in this video we shall be looking at modulus and argument of complex numbers. So I'm going to use the question here to explain how to find the modulus and complex number, the modulus and the argument. So now when you are finding modulus or the argument of a complex number, the first thing you have to do is to write the complex number in a polar form. Write the complex number in a polar form. Now we know that complex number in polar form is r into bracket cos theta plus I sine theta. So this r is the modulus, this theta is the argument. Okay, so now what do? We are going to simplify this complex number given here, 1 plus I in bracket 2 plus I in another bracket all over 3 minus I. So we are going to simplify this numerator here. Let's simplify the numerator. That is 1 plus I, 2 plus I all over 3 minus I. So we expand this bracket here. 1 times 2, that's 2. 1 times plus I, that will be plus I. Then plus I times 2, that will give us plus 2I. Then I times I, according to the properties of complex number, we know that I times I will be I squared, which is equal to what? Minus 1. So I times I will give us minus 1 here. Then all over 3 minus I. So now you collect your terms on the numerator, which is 2 minus 1. 2 minus 1 is 1. Then I plus 2I, that will give you 3I all over 3 minus I. So at this point now, we are going to get the complex conjugate of this. The conjugate of the denominator is going to be 3 plus I. Okay? So now what you do with that conjugate is that you multiply that conjugate by the numerator and multiply it by the denominator. So at the numerator, we have 1 plus 3I times the conjugate, which is what? 3 plus I all over 3 minus I times 3 plus I. So now we go ahead now to expand the numerator, which is 3. 1 here times 3 is going to be 3. 1 times I here is going to be what? I. Plus 3I times 3, that will give us plus 9I. Then plus 3I times I, you know, I times I is minus 1. I times I is I squared, which is equal to minus 1. So minus 1 times this 3, that will give us minus 3. Then all over. Now, if you look at the denominator, this is difference of two squares. This is difference of two squares. If you expand this denominator, you are going to have, we have 3 here, 3 here. So that will give us 3 square minus. The reason we have minus is that minus times plus is minus. So I times I, that will give us I square. And I square, as we know, is what? Minus 1. So that will give us minus 1 square. Okay? Or minus 1, there is no square. Now, we collect like terms at the numerator. This 3 plus 3 will cancel minus 3 here. So we have I plus 9I, which is going to give us 10I all over. Now, 3 square is what? 3 square is 9. Minus times minus here will give us plus 1. So that will be 10i all over 10. So 10 will cancel 10. So we have I. Okay. So now we have I here. So what we are going to do now is to find the modulus. So we'll find the modulus, which is R. Now to get the modulus of a complex number, you are going to say that modulus is equal to square root of x squared plus y squared. So in this case now, this y is the imaginary part, this x is the real part. So with this complex number, this number is purely imaginary because there is no real part of the complex number. So it's purely imaginary complex number. So now that means that there is no value of x. So since there is no value of x, we can say that x is what? 0 squared plus this I has a coefficient of 1. So that will be 1 squared. So this will give us 0 squared is 0 plus 1 squared is 1. So this will give us square root of 1. Square root of 1 is equal to 1. So that is the modulus. That's the modulus of the complex number. So now let's go and find the argument. The argument which is given as tan inverse of y all over x. Now in this case, we do not have any, you see the complex number, we do not have any real part of the complex number. Okay? Now we have 1. Now if you press your calculator, tan inverse of 1 is equal to 45 degrees. But in this case now, we express these arguments in form of radians. In form of radians, not degree. So now this 45 degree now, if you want to turn it to radians, it's going to be pi all over pi over 4. Now pi is equal to 180. Pi is equal to 180 degrees. So if we divide 180 by 4, it's going to give us 45. So this 45 degree now, we can write it in radians as pi all over 4. So this is going to be the argument of the complex number, and the modulus of the complex number is equal to 1.